In this video, I will talk about electrostatic forces. What is an electrostatic force? How to represent it? An electrostatic force is the force exerted by a charged body on another charged or uncharged body. We will see how this happens. And it is a field force, which means that it can act at a distance, which means that there shouldn't be a direct contact for the electrostatic force to act. Let's discuss the first point where we talked about that the electrostatic force is exerted by a charged body or on another object that is charged or on another object that is not charged. Okay, we know that objects are neutral, so they have equal amounts of electrons and protons. I will represent electrons by minus sign and protons by plus sign. So let's assume we have this. This is a neutral object. A negatively charged object is represented by a total negative charge. A positively charged object is represented by a total positive charge. Okay, now, if we have two negatively charged objects, they will interact, they will repel each other. Two positively charged objects, they will also interact and they will repel each other. Why? Because like charges repel means positive with positive or negative with negative, and unlike charges attract. So when we have positive and negative, so when we have positive and negative, they attract. When they repel, it means they push away from each other, so they push away. When they repel, they pull towards each other. Now we describe the first part, which is about two charged objects. They apply a force on each other. A push or a pull is a force. Okay, how about the other part, which is this one, an uncharged body? What does that mean? How can a charged object apply a force on a non-charged object or a neutral object? Okay, if you rub a balloon against your hair, it will acquire a surface charge that is negative. If you stick this balloon to a wall, let's see. First, the wall is, let's assume that this is the wall or the outer layer, which is the paint. It has positive, negative, positive, negative, positive, negative. Okay, it's a neutral. Now, if I take this balloon that we charged negatively and I put it on the surface, or I put it in contact with the wall. So this is the balloon, it's negatively charged. When I put it in contact to the wall, the negative charges are repelled away, most of them, only few are left on this side. Okay, now this side, it's not protons, it is the charge carrier or the nucleus, or the atom, after the electrons are repelled away. So as you see, this wall was neutral, a polarization took place. Now the balloon is attracting to this side. That's why when you do this experiment, you charge the balloon, you stick it to the wall, you hold it for a few seconds, then you leave it, it will not fall for a certain time. Another example that you can do at home, if you rub a comb or even a balloon against your hair and you put it in contact with paper tissue pieces, so small paper, okay, the balloon will attract them. So this is what is meant by it acts, or the force exists even with uncharged objects or bodies. So two charged objects will exert an electrostatic force between them. The nature of this force depends on the polarities of the charges carried by the objects, which means that we have negative and negative, as we mentioned, they will repel. Positive and positive will also repel. Positive and negative, or negative, they will attract. Now, before we continue, so if we have like charges, we get a repulsive force, or there will be a repulsion. If we have unlike charges, it will be an attractive force, or we will have an attraction. So this is what we mean by the nature of the electrostatic force. So in this case, as you see, we have two objects that are positively charged, they are repelling each other away. Two objects that are negatively charged, they are also repelling each other away. And in this case, whether we had positive with negative or negative with positive, they pull. So this is a pull. They pull each other. When it was a repulsion, they push away from each other. Okay. Now we will learn how to draw the forces on each object and how to name the force. Okay. Let's see this force. This is a force, and this is another force. Okay, now this force is pointing to the right, means the red object is being pulled to the right. So who is pulling it? It's the second object, Q2. So this is the force applied by object 2 on object 1. And this force is pointing to the left. So this object, the blue one, is being pulled to the left. Object 1 is pulling it to the left. So this is the force applied by object 1 on object 2. Let's see the other example. 1 is being pulled towards 2. So this is F21. And this will be F12. Okay, now let's go to the other side. Like charges. A Q1 is being pushed away to the left. It's pushed away to the left. This way. So it is being pushed by the object 2. So this is the force applied by 2 on 1. Object 2 is being pushed away to the right. Object 1 is pushing it. So this is the force applied by object 1 on object 2. Same thing for this one. 1 is pushed to the left. So this is F21. And 2 is pushed to the right. So this is F12. So this is for system of electric charges containing two charges. Okay. Okay. How to draw the forces in a system of electric charges that contains three charges. As you see, we have Q1, Q2, and Q3. To draw the forces, separate them. Take Q1 with Q2 first, then Q2 with Q3 second, see Q2 and Q3, and the third case I take the whole system without Q2, so Q1 and Q3, Q1 and Q3. Let's see how we draw the forces. Okay, I will start with 1 and 2. Q1 is positive, Q2 is negative, so they will attract. So I will say Q1 will pull Q2 in this direction. So this is the force applied by 1 on 2. Again, Since it's an attraction, they pull towards each other. So Q1 will pull Q2 to the left. And the Q2 will also pull Q1 to the right. So this is F21. Now, I go to Q2 and Q3. They are also unlike charges, so they attract. Then Q2 will pull Q3 to the left. This is F2, 3. And Q3 will pull Q2 to the right, so this is F3, 2. Now, the third system. 1 and 3. They are unlike charges, so they repel, they push away. Then 1 will push 3 away. We'll push it to the right, away. And 3 will push 1 away. So again, from the beginning, if we have a system of more than 2 charges, what we do is the following. We separate them. I took the first 2 charges, 1 and 2, then 2 and 3, then 1 and... So 1 pulls 2 to the left, 2 pulls 1 to the right. In the second system, 2 and 3. 3 pulls 2 to the right, 2 pulls 3 to the left. And for 1 and 3, they push away. So 1 pushes 3 away to the right, 3 pushes 1 away to the left. If we wanted to combine all the forces in one system where we put the 3 charges together, as we see, I will check. On 1, I have F21 to the right. And I took it from this one. Now from this one, this is Q1, I have F31 to the left. Now for object 2, we have F12 to the left. And if I go to this one, we have F32 to the right. For Q3, we have F23 to the left. And F13 from this one, F13 to the right. So as you see, each object is affected by the other 2 objects. So Q1 is affected by Q2 and Q3, Q2 is affected by Q1 and Q3, and Q3 is affected by Q1 and Q2.